And this is, like I said, one of the earlier stage concepts. So I'm going to try and make this as tangible as possible for everybody here. We're looking at some high resolution fruit. You might be wondering why. And this is because we had at PreScouter, we had a client come to us a few years ago, and they were in the business of making fruit labels. They had a problem that had occurred. They told us that there was counterfeit fruit with their labels entering the market, and the fruit quality was subpar, so it was rotting faster and it didn't taste the same. And there's a lot of quality control mechanisms that go into these type of things, and so they were losing market share, and their consumers were kind of angry or upset with this counterfeit fruit entering the market. As it turns out, the counterfeit business is something that is extremely large. In fact, not just in the fruit industry, but across the entire U.S., it is approaching $1 trillion annually in terms of taking money out of people who have created a product's hands. So they asked us, how can we solve this fruit label problem in a cost-effective manner while maintaining regulatory constraints around the concept of fruit labels, which have their own regulatory um, components. And so this is a very classic technology scouting engagement where we would assemble a team of experts around the space, and we had them search the world for a variety of novel concepts or materials that met the price requirements, regulatory requirements, production requirements, and everything in between. And they whittled it down to around we work with our clients in an iterative or stage gated manner. So it starts at hundreds, then it was like kind of around the 50s, closer to 10, and then by the end of the engagement we came down to 3 finalists. We introduced them to all 3 of those particular technology providers, and the one that actually was essentially the winner at the end of the day was a company creating a nanostructured biomimetic material. Biomimetic meaning something that mimics nature, to the tune of a butterfly wing. So the iridescence that kind of occurs when light hits it in different angles. And what we were able to do is determine that essentially this material or composite was something that would meet the requirements that the client was looking for, and they started to kind of move towards a partnership shortly thereafter. And then hopefully onto production. So the idea here is that this was a smart material that was able to help overcome a really tough challenge that our client was having in a space where it's a pretty tight commodity or the margins are relatively low. So smart materials are basically design materials that have one or more properties that can be influenced or controlled. And so on the left side here, we're looking at sensors. When I was, a younger person at the cutting edge in academia, we called it the S word because it was really easy to make a sensor, but what would it do? And now we find that, these sensor components have been pushed to a price point that are cost competitive, and their efficiency and their performance are on par with what industry needs. So, there's so many types of sensors. I just listed a few here. There are things that can be influenced or give a reaction to light, heat, pressure, pH, other chemicals that are not supposed to be in the environment, or moisture content. And a lot of these things are essentially kind of being applied in a variety of different capacities right now. And then on the other side of the spectrum, we have what I call kind of novel materials, or materials that are kind of bubbling to the surface of productivity on that hype cycle curve, including self-healing polymers or composite materials that kind of reform after there's been a deformation in them. Ceramics are overcoming some of that brittle nature, but even if they aren't, they are proving to be extremely efficient in certain other capacities, such as heat resistance and a few other macro scale challenges that they're dealing with. Graphene, poor graphene has been around for, I don't know, 15. I mean, we've been talking about it for a decade, but it's been around longer, obviously. And we've been waiting to find that nice foothold for industrial application and then have it see its productivity potential. We just launched actually a report earlier this year if you're keen to learn a lot more just about graphene and where it is today. The good news is we're starting to see it produced at larger industrial scales than we had a few years ago. And we're starting to see that once the price point is reaching a certain threshold for R&D departments to start experimenting with it, it is being integrated into components. And of course, it is one of those, miracle materials that is going to kind of be hopefully something that we see a lot more in industrial applications. Aerogels are really fantastic in the sense that they are, lightweight. They're basically gels filled with air, and so they are lightweight. They're really cool to look at, and they have thermal properties to kind of create thermal barriers, and they have a variety of other kind of applications. Metallic foams, we'll talk a little bit about that in the next slide, and then biocomposites. This is assembling anything out of the biological regime in different manners that have been tailored by humans to do something unique or differentiated. And we're starting to see quite a bit of energy and emphasis put into that. The whole entire healthcare sector is looking at biocomposites for novel materials in a variety of different applications. So if we're trying to think a little bit about that smart materials play, and we're that company, that healthcare company that now has predictive immunological data on immunoresponse, well, I would say that we have had this immunosuppressant drug, and now we're going to create a way for it to be payloaded within a biocomposite nanoparticle, perhaps, or some kind of liposomic material, and basically this composite will then deliver the payload that we need at the right place at the right time. If you're in the manufacturing space, those heavy industrial components that have to be routinely moved or moved around, I would be looking at the metal foams area for lightweighting, because although it looks kind of highly porous, it actually can strengthen components while being a lightweighting component. So you actually get a 2-for-1 on that one in the metals, in those heavy machinery components that have a lot of movement typically. And if I were in the CPG or food bev space, I would, actually look at the concept of embedded sensors, because we had a person that was working with us in the cheese space, and they were like, the holy grail is the consumer sees the product, but you can't, the UV light degrades the cheese over time. So that particular wish is a little bit of a high of an ask, but the next best thing you can do is with particular types of foods, you want to make sure that you are keeping people in the loop in terms of their life cycle. So again, pH sensors for cheese. I've lost so many blocks of cheese I can't even tell you, for probably that reason. It'd be nice to have a sensor embedded in it.